Unit 4, Biological Psychology. Presentation 1, The body's response to stress.
In this presentation, we'll be examining the biological changes in the body as it reacts to stress. Although we think of stress in a negative way, we should remember that it is also extremely important for our survival. Early humans evolved a coordinated pattern of bodily changes that would snap into action when they were faced with imminent danger. This response is still important today in situations where the fight or flight response is appropriate.
In fact, there are two bodily responses to stress. One of these is the short-term response for dealing with emergency situations, such as a personal attack or a snarling bear. The other is a longer-term response to a continuing stressor, such as a stressful job or a divorce. Let's begin by looking at how the body responds to short-term stressors.
The short-term response is referred to as the sympathomedullary system. The word sympathomedullary can be broken down into two parts, sympatho and medullary. The sympatho part comes from the sympathetic branch of the autonomic nervous system. The autonomic nervous system looks after the body's automatic responses. The autonomic system looks after functions in the body that are best carried out without us having to think about them, such as controlling the beat of your heart or your breathing. The autonomic nervous system, or ANS for short, is divided into two separate branches. One is called the sympathetic nervous system, and the other is the parasympathetic nervous system.
OK, I've got that. We have a sympathetic and a parasympathetic nervous system, and together they make up the ANS. But what do they actually do?
Well, when we encounter a sudden stressful event, such as a mugger or a snarling bear, the sympathetic branch arouses us to be ready to fight or to run away. Fight and flight are adaptive changes because they are more likely to keep us alive than the response of freezing with fear. The parasympathetic branch has the opposite effect. It makes you relaxed. In fact, it is also referred to as the rest and digest state. So far, we have covered the sympatho bit of the sympathomedullary response. The next part is the medullary bit. This refers to the adrenal medulla. The sympathetic nervous system triggers a response in the adrenal medulla, and the result is that a hormone called adrenaline is released into the bloodstream.
And what does adrenaline do?
Adrenaline is the hormone that gets the body ready for fight or flight. For example, it causes your heart to beat faster and your breathing rate to increase. Both of these body changes help in supplying more oxygenated blood to your muscles, and this gives them more energy to fight or run away.
Let's see if I understand this. When we are faced with danger, first of all, the sympathetic branch of the ANS is activated, and this puts our body in a state of readiness. Second, the sympathetic branch stimulates the adrenal medulla to produce adrenaline. Third, adrenaline causes changes in the body that are necessary for fight or flight. How did I do?
Not bad. Not bad at all.
Remind me again where the parasympathetic branch fits into all this.
If we think of the sympathetic branch of the ANS pushing the individual into action, then the parasympathetic relaxes them again after the stressor has passed. So, for example, it slows the heart rate and increases digestion. So we have fight or flight and rest and digest.
So the sympathetic branch prepares us for action, and the parasympathetic returns us to a resting state once the stressor has passed.
If stress continues for a longer period, a second response kicks in. This is known as the pituitary adrenal system.
Can you give me some examples of conditions of longer-term stress?
Something that is ongoing, such as a stressful job or revising for major exams.
I'm guessing that there are two parts, the pituitary and the adrenal.
Yes. We'll start with the pituitary, which is a small gland in your brain. The pituitary is stimulated into action by a hormone that goes by the name of corticotrophin-releasing factor. It is quite acceptable to abbreviate this to CRF, but it helps you to actually know what it means.
OK, what does it mean then?
The letter C stands for corticotrophin. This reminds us that at the end of this process, the hormone that is produced is cortisol.
In the short-term response, we ended up with adrenaline, and now we're going to end up with cortisol. Is that right?
Yes. CRF triggers the pituitary to release another hormone called adrenocorticotropic hormone into the blood, ACTH. It may be a big word, but it consists of the same familiar parts. A stands for adreno, like adrenal. C and T stands for our old friend corticotrophin, and H is for hormone. Once in the bloodstream, ACTH travels to the adrenal glands. Remember the adrenal glands? For the short-term stress response, the adrenal medulla is activated. For the long-term response, a different part of the adrenal gland is activated. It's the adrenal cortex. Activation of the adrenal cortex leads to the release of cortisol.
Ah, so the adrenal cortex produces cortisol. That makes sense. What does cortisol do then?
Small amounts of cortisol have positive effects, such as a lower sensitivity to pain and increased release of glucose for the continued energy supply. In the short term, cortisol also protects you against becoming ill, but in the longer term, cortisol has a negative effect on the body's ability to fight off infection.
There is just one more thing that confuses me. I now see that there are two systems, the sympathomedullary one and the pituitary adrenal one. But do these two systems happen one after the other? In other words, do you first have a sympathomedullary response, and then, if stress continues, the pituitary adrenal response kicks in?
That's a good question. Actually, they both start off at the same time. The sympathomedullary system fires off immediately, just like lighting a match. A longer-term pituitary adrenal response is more like lighting a fire. It takes a lot longer to get going. So, from the moment a stressful situation begins, adrenaline is released almost instantaneously. However, it takes about 20 minutes before we get to the point where cortisol is released.
Does cortisol just go on being released as long as the stressful situation continues?
Yes, but there is a really neat feature of this system. It regulates itself. If cortisol levels rise too high, they cause a reduction in CRF and ACTH levels, so the whole system returns to normal.
Evaluating the body's response to stress. The stress response, as we have seen, is an important adaptive system. However, in some situations, it can have negative consequences for the individual. For example, if the short-term response is repeatedly activated, the result is that the heart and blood vessels start to suffer from abnormal wear and tear, and this may lead to health problems. The long-term response, as we have seen, can have a negative effect on our ability to fight off infection. Under conditions of prolonged long-term stress, the higher levels of cortisol produced as a result of the pituitary adrenal response can have a number of negative effects. These include lower levels of immunity against colds or other diseases caused by viruses or bacteria. It can also lead to decreased cognitive performance, particularly the ability to retrieve long-term memories.
Another critical point to make about the stress response is that there may be gender differences in how people respond to stress. Until fairly recently, it was believed that the fight or flight response applied equally to males and females. However, psychologist Shelley Taylor and her colleagues provided evidence for a different kind of stress response in females. In stressful situations, women are more likely to protect and nurture their children and turn to social networks of supportive females. Hence, this female response is called tend and befriend. These behaviours would have become more widespread over millions of years because successful tenders and befrienders would be more likely to have their offspring survive and pass on their mother's traits. What can we conclude? The body has evolved a finely tuned response to two different kinds of stress, short and long term. These responses evolved to increase our chances of survival, but with modern stressors, where fight and flight are not appropriate responses, they can actually damage our health. This makes our ability to manage stress all the more important.